In injection technology, the moisture condition of the substrate is one of the most important factors influencing material selection, adhesion, and effectiveness. Different substrates, whether concrete, masonry, or stone, can be dry, damp, wet, or saturated, and each condition requires a specific injection approach to ensure long-lasting leak sealing and structural reinforcement. Ignoring substrate moisture levels can result in 1. Poor adhesion of injection materials. 2. Premature material failure. 3. Incomplete penetration and sealing. 4. Reduced waterproofing performance. So let's talk about the types of moisture conditions in substrates. 1. Dry substrates. No visible moisture, typically occurring in indoor environments or heated structures. Partially wet due to residual or intermittent moisture. This can lead to poor reaction of certain resins, which is based on moisture-cured mechanism. May cause excessive waste of injection material by flowing away. Requires no expanding resins for effective sealing. For example, a warehouse concrete slab with no exposure to water or humidity. So what's the suitable injection solution? Epoxy resins is ideal for structural bonding in dry cracks, providing high-strength reinforcement. 2. Damp to wet substrates. Moisture is present or a surface visibly wet, but not actively flowing, typically after rainfall or often occurs due to groundwater absorption. Partially wet due to residual or intermittent moisture. This reduces adhesion of rigid injection resins. Requires resins that can cure in wet conditions. Limited volumetric expanding resins for effective sealing. For example, tunnel concrete segment wet cracks without active leakage. So what's the suitable injection solution? Polyurethane resins expands and bonds in moist environments. Slightly volumetric expansion resins are ideal as they react with water to form an expansive foam, filling cracks and voids, but still maintaining the good mechanical properties because of closed cell structure. Microfine cement suspensions fills larger voids in damp substrates. 3. Water-saturated substrates. Completely saturated with trapped moisture, but no flowing water. Continuously exposed to water. This requires injection materials that displace water. High risk of resin dilution if incorrect materials are used. For example, a retaining wall with constant groundwater contact, making it fully saturated. So what's the suitable injection solution? Polyurethane resins expands and bonds in moist environments. Volumetric expansion resins are ideal as they react with water to form an expansive foam, filling cracks and voids. Acrylate gels penetrates saturated cracks without losing effectiveness in wet environment. 4. Actively leaking surfaces, hydrostatic pressure conditions. Water is actively flowing through cracks or joints, often under high pressure. High hydrostatic pressure creates complex sealing challenges. Dual component systems with rapid reaction times ensure reliable sealing under extreme conditions. This requires fast-reacting, highly volumetric expanding resins. Needs sequential injection methodology for complete sealing. Release the water pressure prior to injection if able. For example, a leaking underground parking structure with continuous water infiltration. So what's the suitable injection solution? Fast expanding PU foams instantly stops water flow for temporary blockage, followed by PU or acrylate resins for permanent waterproofing and crack sealing. The moisture level of a substrate directly impacts the selection and performance of injection materials. Using the wrong injection system for a given moisture condition can lead to poor adhesion, incomplete sealing, resin washout, or structural failure. By selecting the correct injection material for each moisture condition, long-term sealing, structural stability, and waterproofing can be achieved. Failure to do so can result in repeated water ingress, material failure, and costly rework.